would like to invite the next author. Paper ID is 9407. Self-recurrent neural network-based event-triggered mobile object tracking strategy
407.
for sensor network. Miss Vishwalata Bagal.
Good afternoon, all respected session chair and my friends. I'm Vishwalata Bagal, going to present the paper titled as the Self-Recurrent Neural Network-Based Event-Triggered Mobile Object Tracking Strategy for the Sensor Network. This is the flow of my presentation. The location of sensor node in the wireless sensor network is a very important aspect in many applications. So for that, the tracking is used. The tracking involves the estimation of the unknown variable or the state over the time from the indirect, inaccurate, and the uncertain observations over there. In tracking also, if we want to track the nodes that are mobile, so that is one of the most important feature, that is the mobile tracking in the wireless communication system network. In this paper, I have tried to increase the energy efficiency and the tracking accuracy by using the SRWNN over here, that is the self-recurrent neural network. While preparing this paper, I gone through the various journals. So these are the this is the literature survey for that, and these are the some findings from that literature survey. Here, actually, previously, many researchers deal with the node localization problem that is on the basis of the received signal strength from the different nodes. The RSSI, that is the received signal strength indicator, is used to calculate the location of the target node in the network. But that signal strength, that received signal strength, is affecting due to the environmental parameters such as the padding effect and all, and the undesirable phenomena also there. So there is the noise in that received signal strength. To remove or to minimize the effect of noise from the received signal strength, the various filters are utilized by various researchers over there. So the Kalman filter, extended Kalman filter, basin filters, the unset Kalman filters that are used to improve the tracking performance. So many researchers work on that one. The tracking accuracy in this filtering approach, that is depend on the noise distribution model, which is uncertain most of the real-time application. Like the non-Gaussian nature of the noise distribution that affects the localization accuracy. The limitation of this stochastic approach that may be overcome by using the machine learning algorithms. These algorithms are used. These algorithms use the various neural network families that is mentioned over here. That is the MLP, RBF, and the RLN. The localization performance of this technique is depend on the activation function. In many algorithms, the sigmoid function is used as the activation function. As this paper is also highlighting the approach towards the energy efficiency. So in that case also there are various protocols are there in that the researcher work. The goal of that protocol was to keep the sensor nodes sensing from the continuously sensing, processing, and transmitting the data through a distributed architecture in terms of clusters or the data flow control. Here, as I told you just before, that is the sigmoid function is used as the activation function in many neural network families. But the sigmoid function is not an orthogonal function, and that results into non-unique and inefficient network parameters over there. So that problem is solved by replacing the activation function with the wavelet function. And the wavelet neural network is used in the field of machine learning. It gives the better convergence rate and the superior training performance over there. Here, the activation function that we are going to use, that is a wavelet function. So the output is the weighted sum of the hidden layer that is similar to ANA. While we are discussing this one, the next part of this, that is the self-recurrent wavelet network that is used over here. Actually, the recurrent neural network that include an internal feedback loop that capture a system's dynamic response without requiring external feedback through delay. It performs good than the forward network. The next part of this, that is the self-recurrent wavelet neural network. It consists of self-feedback hidden layer, which enables the neurons in the hidden layer to store the network's previous knowledge and record the system dynamics response over here. So for that, there is a framework that is used in this paper that suggested target tracking framework is for a distributed sensor network that uses an event-triggered measuring approach to save the energy. This technique is based on the concept that the sensor node is made active only when the target is in the detecting range. This algorithm is divided into three stages, that is the estimation model, conscious algorithm, and the event-triggered strategy of measurement or the event-triggered method. The estimation model, that is a simple filter that is used to get a tentative first approximation of the state. Because of the measuring environment changes over the time due to the target node's movability. The next stage in this, that is the consensus algorithm, it provides a framework for a collaboration across the different nodes to follow the mobile target. The next stage over here, that is the event-triggered strategy or the event-triggered method. Actually, in paper, the mathematical framework is used for making the decision for the node to be triggered to take the measurement is presented in the event-triggered strategy, which is used for the achieving the energy efficiency. In this, the evaluated values of the prior estimation state and the corresponding covariance matrix are used to make the decision. Here, the simulation is conducted for that framework. For that, a wireless sensor network environment with 15 nodes distributed over a 100 by 100 meter square range region is considered. The state estimator performance is measured in terms of tracking error, then the wavelet neural network estimation error, and the tracking output. While the system tracking performance is measured in tracking error, the wavelet neural network's performance as the functional estimator is measured in the estimation error. Here, the Mexican hat wavelet is used as the activation function as it is a efficient time space. It is having a efficient time space here. We can see the result for the tracking performance of a proposed strategy. The red line shows the desired trajectory over there for the mobile node, and the green one shows its tracking. The tracking, here we can see that the tracking is quite accurate, and the time it takes this system to track the required trajectory is very short. Here we can see the tracking accuracy in terms of the estimation error with respect to time. It shows that in presence of system dynamic uncertainty and there is no measurement, the predicted target trajectory is giving the good output over there. The conclusion, the combination of this fundamental estimate model and or the framework that is used over here, that is simulated to check out and demonstrate the proposed usefulness and the efficiency. This simulation result shows that the suggested approach performs very good in the existing strategy in terms of tracking performance, tracking error, and the estimation error. So this is the conclusion, and these are some references. Thank you.
Ma'am,
Yes, sir.
what your work is there?
Yes, sir.
If I correlate with the previous work,
Yes.
how you would like to highlight one point which is better
Sir,
than others?
actually, speed of operation is more as we are using this self recurrent wavelet neural network over here,
So
as it is going to store the previous information, whatever the previous state of the node, it is going to store that information, and according to that, whatever is the next stage over there, it is going to take the decision. So while taking the decision, the delay is very less.
okay. Okay. Thank you. You can
Thank
stop
you, sir.
your sharing.